Hey everyone, welcome to today's lesson, Unit 6, Chapter 1, Lesson 5. This is the last lesson in this chapter where we are investigating the air temperature in Christchurch, trying to determine what causes there to be different air temperatures on Earth, and specifically during El Nino years, why do areas experience different temperatures than their normal range. We have been using Amplify and we will continue to be using Amplify, but today's lesson we're actually going to use a Google form because if we were in class, this lesson would actually take place in groups and doing it. And the Amplify website doesn't actually have the space online to answer the questions because this would normally be something that would be handed in on paper inside of the classroom. So I created a Google Drive, a Google form to have you guys answer this question. So to get started, make sure that you guys are logged into the Google form, and the first page should bring you. Let me go to the preview form. Should bring you just to write your name and your class number. At this time, it would be best if you guys did that now. So I'm going to write Leonie for my class, and then I'm going to write all class. Must be a number. Okay, great. So I'm just going to put 1000. Okay. Click the next button, and that would actually bring you to our warm-up question. You can leave this open or with the video and come back and forth between this and the slideshow. So today we're going to be kind of wrapping up this chapter and explaining temperature and how temperature is pretty much determined in regions of our planet. So our question is, why is Christchurch, New Zealand's air temperature cooler during El Nino years? Below are the claims that answer the question, but what I'm asking you guys to think about is which one is the least convincing. And so our claims are the amount of incoming energy from the sun changes, something about Earth's surface, land or water changes, or something about the air changes. Again, you would go right into our Google form here to answer this question. And this is mostly an opinion question. And what we're trying to figure out is which one seems the least likely? Which one seems the least likely to be the answer to why the temperature changes? Claim 1, the amount of energy from the sun changes. Claim 2, the amount of Earth's surface, land or water changes. Or claim 3, something about the air changes. During this chapter, we've been talking about air a lot and how the temperature of air is distributed or acquired. And from what we know, that the temperature of air is required from the sun heating up the surface, and then from the surface releasing that temperature or transferring that temperature up into the air right above it. So key parts of what makes air temperature is the sunlight, the type of surface, and the air above the surface and how easily it's going to be acquired from there. Now, we know that the amount of sunlight an area receives is related to how close to the equator they are. And the closer to the equator they are, the hotter it's going to be. But this doesn't really help us understand why something would change over time. So at this time, I would like you just to select a claim. I'm just going to pick number 1 because it's the first one. And I want you to kind of come up with a real reason why you might think that this would be your answer at this point. All right, so I'm going to go back to our slide here. And when we look at the chapter 1 question, it says, what determines the air temperature of Christchurch, New Zealand? And as of right now, our only real information we have about that is location, how close it is to the equator. And we've learned this through the maps that we've seen, the charts that we've seen that show the different temperatures during based on location. The only deviances we see are when there's a mountain range. And again, we're going to talk about that later on. So what can determine? What changes could happen that might actually cause El Nino years to be different? So we have the 3 things that you would have been working on in class, and it's pretty much explaining your thoughts about what could have happened. On the pages, you'll see on the left side, the 4 vocabulary words that you need: energy, latitude, temperature, transfer. Every answer you give must include all 4 vocabulary words to explain yourself. In green, we have the question that goes along with the map and data table on the page. So in this question, we have, in this scenario, we have, why is the average temperature of Makassar warmer than the average temperature of Christchurch? So why is it warmer? We look at the 2 temperatures and we have Christchurch at 11 degrees and Makassar, Indonesia is at 27.5. Again, I'm using the Celsius numbers because in science, the universal system is the metric system. Now, looking at this map here, I can see that Indonesia is much closer to the equator than New Zealand. And we know from our previous lessons that the closer you are to the equator, the hotter that the temperature on average is going to be. So to answer this question, which if you are now inside of the Google Drive, you'll see that again, I have the list of the vocabulary words. And I have the diagrams here nicely outlined for you. And down here is where you would answer your question. So I'm going to give you guys an outline of how I expect you to answer this question. And the temperature is warmer because it is closer to the equator. This is one basic sentence, but I'm asking you to use energy, latitude, temperature in transfer. So far, I've only used the word temperature. I can write the equator is the latitude line. Again, latitude is one of the vocabulary words that receives the, the most sunlight, comma, or energy. More energy is transferred to the surface and then to the air above. Now, I think I've used every single vocabulary word to explain why Indonesia would be warmer than New Zealand. And if you see here, Indonesia is about 1 to 5 degrees south, and Christchurch is about 45 degrees south. Again, bigger difference between how close they are to the equator. New Zealand is obviously going to be a colder place because it's further away from the equator. Click on next. And if I go back to my slideshow, the next question, again, is the same question, but we're comparing two different places. And it says, why is the average air temperature of Tokyo warmer than the air temperature of Christchurch? Again, it's the same question outline, but we're looking at two different cities. And if we look at this city, I'm going to go to our Google Drive, our Google Slide, our Google form. And I'm going to look at this map here. And Tokyo is about 35 degrees north, and Christchurch is about 45 degrees south. So again, Tokyo is still closer to the equator. So you can actually use the same outline as the question before to answer this question. Again, this might be a good time to press pause so that you can answer the question. I'm just going to write the word answer so that I can go on to the next question, which is our final explaining thoughts, number 3, which compares Reykjavik, Iceland, and then again Christchurch, New Zealand. Now, what's different here is that in Iceland, the temperature is actually cooler. So we're lower than New Zealand. Even though they're lower, even though it's comparing for a colder place, the reasoning and rationale is still the same. This time, instead of Christchurch being colder, it's warmer, and it's for the same reason. It is now closer to the equator than the other city. So if we compare New Zealand and Iceland, New Zealand is still closer to the equator. Now, if air temperature was 100%, if this time you should press pause, come back when you've answered those 3 questions. Make sure you use all of the 4 of the vocabulary words in each answer. Okay, welcome back. All right. Before we begin, I want you to think about the idea that we're looking at a change of temperature. When we talk about El Nino years, and we're talking about why Christchurch has a different temperature average than normal during these times, New Zealand doesn't change locations from the equator. So we're going to look for other aspects that might actually cause a difference in temperature, because the location of the place that we're looking at is not changing. All right, and here we have a letter from Kiri Parata. And again, if you look inside of, I'm going to write answer. I also put the letter up here so that you guys could get the information. It says, now that you've learned more about what determines a location's temperature, and again, that's mostly how close it is to the equator, you are ready to begin helping us determine why Christchurch, New Zealand's air temperature is cooler than usual in El Nino years. I'm sending evidence that might help you with this investigation. Please review the evidence carefully. Remember, your research will help the farmers be better prepared to protect their crops and livestock from temperature changes in the future. So again, we're looking to help these people understand the differences in temperature, what causes it, and potentially giving them ways to control their environment to make it better for their livelihood. So I want to evaluate the evidence that we have here. And on the map, on the charts, which you have also on the Google Slides, it has blue for a normal year and orange for an El Nino year. And the charts that we have available to us are the average air temperature, the average ocean surface temperature, and the energy from the sun at Christchurch, New Zealand. If we look at just the air temperature, we have here that during a normal year, it is about 12 degrees Celsius, And during an El Nino year, it's about 11 degrees Celsius. Lowering by 1 degree, and again, as mentioned earlier in the unit, even 1 degree can change how the living things in an environment react to each other. In the second, we see that the ocean temperature also goes down by 11. It starts at 13 and goes down 2 degrees. Now, if I were to compare the ocean to the air, I notice that in a normal year, that the temperature of the ocean is 1 degree higher than the air. But when we look at an El Nino year, they both drop to the 11 degrees. So there's a bigger difference between the air temperature drop and the ocean drop by 1 degree. But in all, both the water and air drop 1 degrees. Then the third chart shows the energy from the sun. As mentioned before, New Zealand is not changing location, which is why it's not surprising to see that they have the same amount of sunlight during a normal year and an El Nino year. Now, this to us might seem kind of confusing because we know that sunlight is directly affects temperature based on our understanding of the relationship between the equator. We know the equator gets the most sunlight, therefore it is the hottest. So if the sunlight is not changing, we have to look at other aspects that might change the temperature. Now, we don't have any other evidence besides this right now, but when we look at what I'm asking you to do today, I want you guys to look at these charts and see if any of these support or go against the following claims about Christchurch. And the claims are actually above. And so it's the amount of incoming energy from the sun changes. Now, based off the last graph, which is right here, there isn't any change. Now, claim number 2 says something about the Earth's surface, land, or water changes. This actually might be supported based off of this graph. And then claim 3 is that something about the air changes. Again, not proving or disproving, but it does show that there is a change in air. So for today's assignment, make sure you can write 1 to 2 paragraphs and explain, do any of these graphs prove or support or go against any of the following claims? And at this point, we can pretty much rule out claim 1 because the amount of incoming energy from the sun changes, which we see in graph 3, it doesn't. So far we're still left with claim 2 and 3, but I want you guys to explain why these graphs would support or go against, or another way to say that is refute, the claims above. It's going to take you a few minutes to do that, but the video is over. If you have any questions, please reach out. Thanks, guys.